So Altair Inspire tool enables design engineers to make a right design decision, starting from designing a part, analyzing the part, optimizing it, and also choosing the best manufacturing method for that particular for the design. Saying that, let's talk about how it really works. So let's say for example, I want to design a part and in the end manufacture a part for laser powder bed method, or SLA method, for example. So for a design engineer, the process starts with capturing loads and moments and torques, operating conditions in a sense from assembly. From there, we get into the topology optimization. So Inspire come up with the best possible design with the given manufacturing constraints, such as for casting, for machining like a milling, or for 3D printing. So for 3D printing, we also added a overhang shape control. So I can come up with a design which requires zero supports, essentially self-supported part while I'm printing the part. Then I can take that part in a virtual printer, print bed, where I can create supports, edit the supports, optimize the orientation for that particular part, and then finally get into the print simulation. So print simulation helps me understand while printing the part, if this part is going to deform, if it is, in which direction it is going to deform, which parts I can change if you want to modify. Looking at the temperature and the deformation for the printed part or from the print simulation. For example, looking at this area, we get a lot of less displacement, for example. But in other areas, such as this leg over here, they are deforming a lot. And that Inspire predicts that while printing, while doing the print simulation. Now, I have two options. I can go back, start changing the print parameters in the printer machines, and maybe do a trial and error to figure out the successful print in the end. But the better way is I can go back to my designs and make design changes very quickly, very small design changes, which won't affect my part itself, but it will make my life easier when I go downstream during the print process. Now, that was a process for if I'm doing a SLM or the laser melting as a manufacturing method. But I can also do the method for milling operation. Again, it goes back to the Altair's or Inspire's philosophy about choosing the right method, design method for particular manufacturing process. Now, said that this is the same, starting point is the same, where we capture the loads automatically for an assembly. Inspire does the topology optimization, and in this case, I told Inspire to come up with a design for milling operation or CNC operation. And now we can see the design looks much different than what we saw earlier for the SLM process. Now from there, we create geometry, automatic geometry from our newly developed tools, which we can take, they prepare for the milling operation, but at the same time, I can check the part's feasibility, structural feasibility using FE analysis. I can look for the displacement, deformations, stresses, von Mises stresses, and finally, we can render this part in our Inspire Studio feature. And as you can see, going back from this year, there are the different processes we talked about, as in LPBF, traditional casting, hybrid casting, where we can 3D print the sand core and then cast the part. And for that, we can also do a casting simulation. And the process again starts here. We come up with a design, and then we can go jump directly into the casting simulation to find out if I cast this part using high pressure, low pressure, or investment casting, is there going to be a problem? If there's going to be a porosity, if yes, I can go back to my design parameters and make a design change. Again, small design change to save the cost at the end of the casting process. Using this exact mechanism, we come up with different designs for the same exact application. Now, the first application I want to show you is we printed with a Rennie shop. It's a SLM LBPF method. Now, this design was with a no support structure. So the design for additive manufacturing, So in this case, we designed a part such that it requires zero supports. That's the best design for an engineer, where I don't have to spend time post-processing, cleaning up supports, and at the same time, I don't want to waste the material and again save the cost in the end. So this is a design for SLM or the Rainy shop process. The second design I want to show is this is the casted part. Very similar design, small changes again to make sure this is casted part is successful every single time. The next design is more of a traditional design where we have a milling operation in two orientations. So the design actually come up with holes and the sockets such that I can orient this part in just in two orientations in a machine shop and get the part. I can say the design between the machining and the 3D printing is really different, but both have their advantages, and again both have their the shortcomings in depending on the manufacturing process. Both designs are good designs. They satisfy my design criteria, loading conditions from that we captured in our motion simulation. They both, just the manufacturing method is different. The last one I want to show you is a binder jet design. This is a binder jet design, and this is a design for the FDM, fused deposition metal. Again, for the same bracket, the designs look much different because the manufacturing requirements for those processes are different from what we saw in the SLM and the machining. For example, let's talk about the FDM. The most critical constraint in the FDM method is during the sintering process. So printing is pretty easy part for the FDMs or the binder jet. But when they put this green part into the oven, the part shrinks. And typically the part shrinks toward the center of gravity. And in Inspire, we can assign the center of gravity as a manufacturing constraint, and so that the design looks much different than what we saw for something else. Again, it goes back to the philosophy of Inspire, as you can see on the top, is choosing the best manufacturing method by an engineer, by a designer, to come up with a particular design.